Actually, all right, thank you guys for being here. Thanks to Tyler again for organizing such a successful meetup, drawing the big crowds, and thanks to Jason also for a fantastic presentation on architecture. So just one caveat on this. As Tyler mentioned, I taught a boot camp. We covered Redux Saga, promises, and generators. I think in total I probably lectured for maybe like 2 hours about that stuff. And today I'm going to be presenting this in 20 minutes. So things are going to go fast. This is probably new stuff to a lot of you, but I hope I do a good job of at least explaining it to the point where you're comfortable going online and learning stuff on your own and continuing to learn about this stuff. So I'm going to start my timer so I don't ramble too long. All right, and one other quick note, as Tyler mentioned, the boot camp I was running just finished. We had 8 students for 12 weeks, 40 hours a week. And if any of you guys, we just finished last Friday, and so the students are starting to look for jobs. Some of them are actually in the audience right now. So if any of you guys are hiring junior developers, please reach out to me, and I'm happy to make an introduction to any of my students. Cool. All right. So we're going to talk about Redux Saga. How many of you guys are familiar with generators in JavaScript? Okay, decent number. I was hoping it would be nobody so that when I say something that's completely wrong, no one would correct me. But basically, what Redux Saga does is it uses generators as an alternative to action creators that return functions or thunks, which is what Jason proposed doing earlier. And you would use these to manage your asynchronous code that's communicating with the server or doing other asynchronous tasks. And we'll see some examples of those in a bit. So we could use asynchronous action creators that return a function, that return a promise, or that have callback functions. But all of that gets very confusing, and it would be really nice if we could write our async code in a synchronous style. So this is what I mean by that. So if we want to have a function that's going to collect some data fetch some data from the server, and we want to dispatch a few actions to a Redux reducer before and after we make the API call, it would be really nice if we could just do that in 3 lines of code like this, where we just dispatch a fetching data action that's going to change the UI state to indicate that we're making an API call. Then we just actually make the API call, save the data in a variable, and then once that's done, we don't want this to block the application. And once it's done, we'll just put that data back to the reducer just by dispatching it. So this is very simple, very easy to understand. It looks like it's synchronous, but it's not actually going to block the code when you're using Redux Saga. And it will look almost like this. We'll just have a little bit of extra syntax because we'll be using generators. So what are generators? Here's an example. I was working on these slides over 4th of July, so my examples are a little bit patriotic. So here we have a generator function. You can tell it's a generator function because we have a little asterisk here. So if you have a function star, that means this is a generator function. You could also put the star before the function name if you prefer that style. Doesn't really matter. And then when you call this generator function, it returns a generator object, which we're then storing in this constant. We're storing a reference to that in a constant called Lincoln. So then we can do what's called iterating the generator. So when we call this function, nothing actually happens. We just create a reference to a generator object, but no code is run. So then when we iterate the generator by calling the next function on a generator object, the first time we do it, it will start at the beginning, and then it will run until it reaches a yield statement. Then once it reaches the yield statement, the next function is going to return an object with 2 properties. The first property will be value, which is just the thing that we're returning. Here we're just returning a string. It could be any other thing. And it will have a property done, which is false until the generator function is done and there's nothing left to yield. So then after we've iterated the generator, it will run this until it hits the yield, and then it will pause the code here and it will remember where it is. So then we can do something else in our application. or not. We don't have to. We could iterate again right away. And then the next time we iterate, it will start again here and continue until it hits the next yield statement. And then in this example, if we iterate a third time, there's nothing left to yield, so we just get an undefined value, and done is true the last time we call next. So generators make it really easy to write asynchronous code in a synchronous style. And the way you do that is you yield on a asynchronous function call, and then you have that asynchronous function iterate the generator once it's done. So you could do that with promises, you could do it with callbacks, whatever you prefer, whatever the API you're using is going to require you to do. As long as you just iterate the generator, once the asynchronous part is done, it'll resume the generator and keep going. So here we've changed our Gettysburg generator a little bit. Now we want Mr. Lincoln to say 4 then pause for 1 second, and then say, and 7 years ago. So to do that, we just add this line in here, which says, so then when we iterate the generator, it's going to run this part, 4, then it will yield on this delay call. So this generator is now paused, but we've called this function before it paused. So we can do other things, and our application isn't blocked. It's going to, it'll just run as normal. And then when 1 second is up, or however many milliseconds we pass, the function, this callback will be run, and that will iterate the generator, which will make it run the rest of this generator function. So this is a way to write. So it looks like this is a very simple function, but there's actually some asynchronous stuff going on, and it's not going to block the main application. So Redux Saga uses that technique to do asynchronous actions in Redux. But it handles all the middleware will handle all of the boilerplate and all of the tricky parts for you. You actually don't need to know. If you just missed the whole first part of this presentation, if you didn't listen to anything I said, that's fine. You could do Redux. You could do everything you want to do in Redux Saga without ever understanding how it works. It will handle all of that for you. It's good to know how it works in case something does go wrong. But if you're just doing 99% of things you would want to do, you don't really need to understand how the asynchronous part works. We will talk about the things you do need to know for the remainder of this presentation. So let's start with a short description of the application that we're going to build. If you want to check out the code or see it in production mode, the links are there. I'll pull it up really fast. So didn't spend a lot of time on the design here, but our application, there's a Firebase backend to this where it's just a simple database. We are going to, there's two things we might want to get out of this Firebase database. One is like an array of keys corresponding to all the speeches. So we have a Gettysburg key and a Moon key. And then we also can, once we have a key, we can get an array of phrases from that speech. And then our application is going to play those speeches back phrase by phrase with a pause between each phrase depending on how long that phrase was. So a little bit of a contrived example, but it does show off what typical things you might want to do with asynchronous stuff in a React application. So this is how it works. We can choose a speech we want to play, and it will play the speech with a pause between each phrase. We can hit reset and start over. If we hit reset while something is playing, then it will stop playing it and reset. So we don't want the play actions to continue because that would mess things up because we've reset our state whenever we hit reset. So that's how it works. And then so we start by adding middleware to our Redux store. The middleware here is just provided to us by Redux Saga. We don't have to do anything custom here. We just initialize the middleware and then add it to the store. If you want to have multiple middlewares, you can use Compose. to add more than one middlewares if you also want dev tools or something like that. And then after you've added the middleware, you need to run your root saga, which is a function that we wrote. So the root saga is responsible for watching for specific actions and then running worker sagas based on which actions it sees. More specifically, it's actually going to launch sagas that watch, and then those watching sagas are going to run the worker sagas once they see what they're looking for, once they see an action of the type that they're looking for. So Redux Saga provides us with a couple helper functions, take every and take latest, but you can also write your own. These are the watching sagas, but you can also write your own, and I show an example of that in a second. So this is what the root saga looks like. In this root saga, we're going to watch for fetch an action with the type fetch speech keys, and whenever we see one, we're going to run this worker saga, and we'll see what that looks like in a second. And similarly, we do the same thing for the fetch speech actions. So what these are actually doing is they're yielding a fork effect, and we'll talk more about what effects are in a second. But fork effects concurrently alongside each other. So this is what, so just a quick note on what effects are. Effects are just plain JavaScript objects that are then interpreted by the middleware, and then the middleware does something based on what the type of object it received is. So whenever I say something like this is going to yield an effect, or even if I say, I make it sloppy and say this saga is actually going to make an API call, that's wrong. The sagas are just yielding these plain JavaScript objects, which then get interpreted by the middleware. So you can think of our sagas as pure functions. They don't have any side effects. They're not actually changing the state on their own. Instead, they're just emitting these plain objects, and they're pure, so they're consistent every time anytime they get the same input, they'll have the same output. Okay, so for this watcher saga, I'm not sure if that's a real term or if that's something I've just made up, but there's an infinite loop here. It's okay to have infinite loops in generator functions because it's not going to run forever. It will pause until it hits a yield statement. So this is just saying continue doing this for the whole life of the application. Never stop watching for these actions. And then we're going to yield a take effect, which tells the Saga middleware, pause this generator until we see an action that matches this pattern, until we see an action whose type is play speech. And then we're going to use a race effect, which races two other effects, or as any number of other effects, and as soon as one of those effects finishes, then it will cancel all of the other worker sagas or effects that haven't finished yet. So here, what we're doing is we're saying, call this worker saga, which we'll see in a second, but this worker saga is going to display all the phrases with a pause between each one, but race it against this effect, which is looking for a reset action. So this means if we see a reset action before we finish playing the speech, then cancel playing the speech. We're just racing these two things. Whichever one doesn't win gets canceled. So this is what the worker sagas look like. These are fairly simple, but there's really no reason to make them more complex. They aren't simple because this is a simple example. This is really about as complicated as they need to be in a typical production application. So let's just look, they're pretty similar, so let's just look at the second one, which is a little more complicated. We're using 3 different effects here, call, put, and select. So first we use, when we fetch a speech, that means we have a key for the speech that we want, Moon or Gettysburg, for example, that's already in the store. So first we need to figure out which speech we want to fetch from the database, and we do that using a select effect. So this tells the middleware, go look at the store and run this selector function against it, and give us whatever the current speech is, and save that in this key constant. And then we're going to yield a call effect, which we saw in the previous slide, but we can talk a little bit more about it now. It's going to call this fetch Firebase function, which is a function that we wrote that just returns a promise. And then once the promise is resolved, it has the data from the database that we're querying. And we use the key that we fetch from the store to as a parameter to this fetch Firebase function, so we get the right speech from the database. And then once this is done, so this is an asynchronous function. It's going to return a promise. So the middleware is going to pause here until this has been resolved and save the result of this API call in this data constant. And then, so once this is done, once the asynchronous function is done, we're going to yield a put effect, which just sends an action object to the reducer. So this is just my action creator. It takes the data from the API call and returns an action object, which I then send to the reducer, or the middleware will send to the reducer because it sees this put effect. So these are very simple sagas. Again, if you're just doing an API call, it doesn't need to be any more complicated than this. But they can be arbitrarily more complicated. So for the saga where we actually play the speech, we want it to do three things. We want it to check if the speech has already been completely displayed, and if so, clear it so we can play it again from the beginning. We want it to, and then once that is done, we want to dispatch a display phrase action for each phrase that hasn't been displayed yet. So that will tell the reducer to start showing these things in the component. And we want it to pause between each phrase, except for the last one, for an amount of time that varies based on how long that phrase was, how many words were in that phrase. So that's what this code does. So there's a lot of branching logic in here, but it's pretty easy to read. So first we select the data from the store using these select effects that I talked about earlier. Then we check just with the simple if statement to see if all of the phrases have been displayed. If they have, then we want to clear the speech by sending a clear speech action to the reducer and reset the displayed count because now it should be 0. And then we'll just loop starting at the last phrase that was displayed and send out a display phrase action for each of these phrases. And then between each of them, because we're in a loop here, we're going to yield a call effect on a delay function. This is actually provided to us by Redux Saga, but it's similar to the one that I showed before, how you would, it's just a set timeout that will iterate the generator once it's done. And we delay an amount of time based on the number of words from the phrase. So this saga is a little more complicated. It has a lot of branching logic. There's a loop. We might want to write tests for it. And this is one of the major reasons that you should be using sagas, is that they're really easy to test. So let's look at what these testing look like. So first, some examples of how you might test the simple fetching sagas that we saw earlier. This is what the function looks like from the previous slide. These are tests written in Mocha and Chai. Oops. So to test it, we're just going to keep iterating it, and each time we iterate it, we're going to check what effect it yields. So the reason we can do that is these sagas are meant to be pure functions. They're not going to actually execute any side effects. They're not going to execute any other functions. They're just going to return objects, which then get interpreted by the middleware as instructions and as to what functions they should call. So when we're testing sagas, we just need to check that the objects that they're yielding are the correct objects. So here we first iterate it. We expect the first effect out of here to be this call function with the correct argument. And then we're going to take advantage of another feature of generators, which is when you set a variable or a constant equal to a yield call here, or equal to a yield statement, it will, the next time you iterate the generator, you can pass in data to the next function that you're calling to iterate, and it will save that data in the variable that you set equal to that yield statement. So another great reason to use sagas is it makes it really easy to mock out API calls. We're doing that here just with a simple example, but you might test what happens if there's different states. If you want to like branch this logic to show errors or something on if there's an API error. And you don't have to like use sign-on or anything like that to stub out functions, to stub out API calls, because it's never actually executing the API calls, and it will take the data that you give it in your test without any complicated stubbing logic or mocking logic. So here we're just saying we expect the second effect to equal this put action, and then we want to make sure that the worker saga terminates after that. So we just iterate one more time and make sure that done is equal to true.
Quick question.
Mm-hmm.
Can you nest these generators?
Yes. Yes.
So a generator can yield another generator?
Yes. And so they're composable. You can have a generator yield another generator, and then it will go through all of that generator first. So that makes them even more flexible.
Well, that's pretty powerful.
Yeah. That's actually what's going on in our root saga. So these are other generator functions, and the middleware is going to this is a generator function, and it's actually yielding an array of other generator functions, but it's basically, it's yielding other generators.
Yeah, by using this, completely eliminate the need to use like the async npm package.
Yeah.
Is it awkward to work with promises from generators?
How so? Or why are you thinking that?
If you have libraries that already do some of the stuff for you and they're written with promises, and then you're using them from generators, which are kind of a synchronous style, what does that look like to call out to anything that returns a promise?
So the Saga middleware will handle promises in the correct way. So if you're using something complicated, then maybe not. If you're doing something that's trying to do work for you, then maybe not. But if you're just so for example, this fetch Firebase function here is returning a promise. And once the promise is resolved, it will have the data, like the parse data that we want to insert into the store.
Oh, cool, because I thought this is really awesome that you're writing stuff in a synchronous style, and I thought, does that get hosed if you call out to something that's not a generator, but that's really cool.
Yep. The Saga middleware is going to pause this generator or pause this worker saga until that promise has been resolved, and then just basically do what you would expect with the return value from the promise. So this is the last slide. When we're testing, so one downside of testing sagas is that your sort of naive tests where you just keep iterating and check each value. It depends on how you like to write tests, but one downside in my opinion is that really couples your test to the way you implemented the generator function. So if you change the order that you're yielding these things, like if you decide to, for some reason, like select data in a different order, then all your tests are going to break even though your function still works. But it's possible to write helper functions that can sort of decouple this to some extent. So here's an example where this helper function is just going to continuously iterate the generator until it's done, save all of the effects in an array, and then we can just run tests against this array that gets with that has all of the effects. So just really quickly here, this test, we want to test the behavior that it doesn't delay after displaying the final phrase. So we can do that without just calling next a bunch of times. We just use that helper function and then check that the last effect that gets yielded is equal to the effect where we display the phrase rather than a delay effect. And this is not necessarily a very good helper function because we're actually still coupled a little bit because we have to tell it which data to put in, but just for the sake of illustration, this is a technique you can use to avoid that downside to writing tests, or to testing sagas. All right, that's all for this very brief presentation about Redux Saga. If you guys have any questions about sagas, feel free to send me an email. And again, if you are looking to hire a junior developer, please send me an email and I can put you in touch with some people who are really good at Ruby on Rails and React JavaScript and have a lot of good front-end skills.
Can I ask a quick question?
Yeah.
Before you close out? So this is Redux Saga, right?
This is Redux Saga, yes.
Does it, I think maybe this was in the beginning and I didn't click until later.
Mm-hmm.
Does this replace actions? Does it go inside actions, replace the async? Does it still like end up communicating back to reducers, or does it like sort of remap the way that Redux behaves?
It's just a middleware. So you can use this alongside your asynchronous actions, or your thunks, or whatever you want to call them. However, I would say like so it's nice because you can refactor it. If you decide you want to use sagas, but you already have a lot of code written that's using thunks, then it's pretty easy to incrementally refactor things. You can just change, but I would say you should change one action from a thunk to a saga at a time and not try to do both on the same action. It could probably work. I just haven't thought too much about that.
So if you were going to use this, would you end up embracing it? Like if you had existing actions, you just convert them. Like would it be easiest to just convert them all to sagas and then
You can. You don't have to though. You can. It's perfectly valid to use them alongside each other in the same application.
All right. Let's talk more about that.
Sure. Does anyone else have any questions?
How valuable are there Saga libraries that are outside of Redux? So it sounds like since they're just using generators and maybe some middleware that you would totally see sagas in the Angular world, for example.
Yeah, that's not something I know a lot about. I would say that.
But they're not tethered to Redux. Saga is tethered to Redux, but like if your app didn't use Redux because it's really small or something, you might find yourself using sagas without Redux.
Yes, but I would say that the main advantage of Redux Saga is that it has a lot of logic to interpret the effects that you're yielding, because then you're able to write your like pure functions. But here, like if you wanted to use generators for asynchronous stuff, it's not that hard to do it yourself. You could just have to, like if you have promises, you need to add another then, which is going to iterate the generator, or at the end of your callback chain, you need to iterate the generator yourself. So Redux Saga does that for you, but that part isn't, I wouldn't say that's, maybe this is debatable, but that's not the only thing Redux Saga does. The other stuff that Redux Saga does is pretty tied down to Redux in particular. Yep. Any other questions? All right. Thank you guys.